All right, forget everything you know about the gold rushes of the past. Seriously, today we are going on a cosmic treasure hunt for riches that are, well, literally beyond imagination. And this treasure? It's floating right now out in that vast, dark space between Mars and Jupiter.
$700 quintillion. I mean, just let that number sink in for a second. That's what NASA thinks all the raw materials in the main asteroid belt are worth. To try and wrap your head around that, if you could somehow divide it all up, every single person on Earth, yeah, you, me, everyone, would get about $100 billion each. It's just staggering.
So, okay, we've got this incredible treasure chest just waiting for us. But here's the catch. It's spread out across millions and millions of different rocks. The challenge isn't just finding a needle in a haystack. No, it's way more complicated. It's about figuring out which needles are just plain old rock, which ones are basically giant floating water tanks, and which ones are solid gold.
So how in the world do you do that? Well, luckily for us, scientists have figured out a way to do it without ever having to leave Earth. It's like they've cracked a secret code, a kind of cosmic alphabet that lets us read the secrets of these distant rocks from right here.
This whole brilliant technique is called spectroscopy, and it's actually pretty simple when you think about it. You know how sunlight hits an asteroid? Well, the light that bounces back to our telescopes carries this unique fingerprint. See, different materials reflect different colors. So, by analyzing that light, it's like we're scanning a barcode. We can tell if a rock is made of iron, or carbon, or just plain stone, all from millions and millions of miles away. It's amazing. And this fingerprinting method is so good. It lets us sort more than 95% of all the asteroids we know about into 3 main groups. Just 3. You can think of them as the big 3 letters in our new cosmic alphabet: C, S, and M.
Okay, so first up, we've got the C-types. C stands for carbonaceous. Now, these are the most common ones out there, but don't let that fool you. They are incredibly important. And you want to know why? One word: water. They are packed with water ice. And in space, water isn't just for drinking. Oh no, it's the key to life support. And get this, when you split it into hydrogen and oxygen, it becomes rocket fuel. So yeah, C-types are literally the gas stations of the solar system.
And when I say they're common, I mean it. A whopping 75% of all known asteroids are C-types. They tend to hang out in the colder outer part of the belt, which is why all that precious water ice was able to survive for so long. And that, right there, is what makes them absolutely essential for any kind of human future in space.
All right, next up are the S-types. S is for silicaceous, which is just a fancy way of saying stony. The best way to think about these is as giant floating quarries. They've got all the basic building blocks we need for future space construction, a mix of rock and common metals like iron and magnesium.
So these guys make up about 17% of the asteroid population, and they're usually found a bit closer to the sun, where it was just too hot for any water ice to stick around. So what's the bottom line? If you want to build a space station or maybe a habitat on Mars, the raw materials you need, basically the space version of steel and concrete, yeah, that's going to come from an S-type asteroid.
And finally, we get to the M-types. M, of course, stands for metallic. And folks, these are the legendary treasure chests we've been talking about. The jackpot. Scientists think these are the actual exposed metal cores of ancient baby planets, protoplanets, that got smashed to bits in violent collisions billions and billions of years ago.
Now, they're pretty rare, making up only about 8% of asteroids, but their potential value is just off the charts. We're talking almost pure nickel iron, but they're also shot through with platinum group metals, and yes, even gold. These are the real prizes, the ultimate targets of this whole cosmic gold rush.
So when you look at it all together, it's pretty clear, right? The water-rich C-types are everywhere. They're absolutely dominant. And that means the really valuable S-types, and especially the M-types, are a much, much rarer find. So this whole thing isn't just some blind search. It's got to be a targeted, strategic mission.
Okay, so you might be thinking all this wealth is just, sprinkled evenly across those millions of rocks. But it's not like that at all. It turns out that a huge chunk of the entire belt's mass, all that potential value, is concentrated in just a handful of absolutely colossal objects.
Check this out. Just 4 of them. Ceres, Vesta, Pallas, and Hygiea. Just those 4 contain over half the mass of the entire asteroid belt. 50%.
All the other millions of asteroids, they're basically just the leftover gravel from the formation of the solar system. And as you can see, one of them, Ceres, just completely dwarfs the rest.
Yeah, Ceres alone is so big it's actually classified as a dwarf planet, and it holds almost a third of the entire belt's mass all by itself. Now remember what kind of asteroid it is. It's a C-type, which means it is the single largest reservoir of water in the inner solar system, besides our own planet. It's not just a gas station, it's a strategic fuel reserve for all of humanity's future in space. Sure, the other giants like Vesta and Pallas are cool, they've got unique stuff going on, but it's the sheer volume of water on Ceres that is the real game changer here.
Okay, so we found the treasure map, we know where the water is, we know where the building materials are, and we know where the gold and platinum are. The next step is obvious, right? Go get it, bring it home, and get rich, right? Well, hold on, because here comes the big twist. Bringing all that treasure back to Earth would be a catastrophic mistake.
And here's why. It's a paradox of value. See, down here on Earth, something's value is mostly based on how rare it is, on its scarcity. If you suddenly dumped thousands of tons of gold onto the market, the price would absolutely collapse. It would become worthless. But in space, value is based on something completely different. Utility. How useful is it right there? Gold is valuable up there not because it's rare, but because it's a fantastic conductor that doesn't rust. Iron is valuable because you can use it to build a space station without having to pay the insane cost of launching it from Earth.
And this is the new mindset. This is the whole point. The real gold rush isn't about bringing treasure back to Earth. It's about using that treasure to leave Earth for good. It's about building a self-sustaining human presence out there in space, using local resources to build the ships, the habitats, and the fuel depots that are going to take us to Mars and then, well, beyond.
So think about this. Is the first trillionaire going to be a person who brings a mountain of treasure home, or will it be a company that never brings anything back? The true wealth of the asteroids isn't in the gold you mine. It's in the orbital shipyard you build with it. It's a completely different way of thinking about what it means to be rich.